So chapter 4 is all about how to prove that triangles are congruent. So this first section just kind of talks about, okay, what does it mean to be congruent and those kind of things. So we've used this word congruent before, but we've used it to talk about congruent angles or congruent lines. Congruent angles have the same measure. Okay, if you took a protractor, they measure the same. Congruent segments have the same length. So when I talk about congruent figures are going to have the same shape and the same size. They don't necessarily have to be oriented the same. So if you look at these two figures here, if you lay them on top of each other exactly like they were, they wouldn't lay on top of each other because this one on the right is flipped over. But if you reflected it, if you flipped it over on top of that one, they would line up right on top of each other. They would be the exact same shape and the exact same size. Now, when we kind of focus in more specifically on congruent polygons, what's important and what's neat about these is they have congruent corresponding parts. And what they mean by that is if you were to lay these two quadrilaterals on top of each other, so they did lay right exactly, so you flip this one over to the right, the angles that match up, so angle B and angle F, they are congruent. They have the same measure. And angle A and E, they have the same measure. Angle D and H have the same measure. Angle C and G have the same measure. And the sides also work out that way. So the top would measure the same. This inside would measure the same. They'd be the exact same. So the corresponding parts have the same measure. Now, up until this point in time, it hasn't really mattered what order, for the most part, you write things in. So if we're talking about a segment, and you want to call the segment AB instead of BA, that's fine, because segment BA and AB, it's the same thing. When we're talking about polygons and congruent polygons, the order of the letters is very important, because the polygons with the corresponding vertices have to be in the same order. So what I mean by that, okay, I said angle A and angle E, those are the corresponding angles. They measure the same, right? They would be the ones that match up if you did lay them on top of each other. So when I'm stating that, hey, these two polygons are congruent, they need to be in the same place in the name. So A and E are both going to be the first letter, okay? B and F are the corresponding angles, so B and F would both be the second letter, okay? And then C and G, you can see that there, and then D and H would be the same order. So the order of the letters is very, very important, okay? Now, it doesn't necessarily have to be A, B, C, D. You could call this polygon C, D, A, B. But if you call this polygon C, D, A, B, you would have to call this polygon G, H, E, F. So you'd have to mix around both of them, okay? Now, what's neat about naming them this way is you don't necessarily have to have a picture. So without this picture, I could tell you exactly which angles are going to be corresponding because of what we just talked about, right? The first letter in each of those is going to correspond to the first letter in the other one. Second letter, third letter, fourth letter, okay? Well, you can take that even a step further because it also works the same way with the sides, okay? AB is going to correspond with EF. And if you look at that, AB is the top, EF is the top. And then BC and FG, that's those sides right there. Okay, so once again, you don't have to have the picture. Sometimes it's nice to have the picture, but you don't even have to have the picture to tell what the corresponding sides and angles are. So we'll practice with that a little bit, but that's, I guess, pretty simple, okay? The theorem that you guys copied in your flip book is the third angles theorem, which just basically says you have these two triangles. In these two triangles, two of the angles are congruent to the other two angles. If that's true, if these two angles are congruent to these two angles, the third angle is also congruent. Okay, so that's the theorem that you guys wrote in your flip book. And what we're going to do, get right into proof. Start off chapter 4 on a green note, and we are going to prove that theorem. Okay, so down here, and I will say a lot of the theorems a lot of the proofs in chapter 4 are going to be shorter proofs. Not this one, but a lot of them are, but they are simpler, I think, in terms of the proofs. Okay, so let's go ahead and let's start this. So just like the proofs before, we're going to start with the statements and our reasons. Just a couple of reminders with your proofs, especially if you're doing a 2-column proof. You want to make sure you number so they correspond. Number on both sides. Okay? We know that the first statement is probably because it is my given. I also know that the last statement needs to say angle C is congruent to angle F. Okay, so kind of thinking about a game plan, because from what I'm gathering from a lot of you guys is that I think you know what you want to say, but writing it into proof is the challenging part. You know how to prove it, you just don't know how to put it into writing. So talk through it first. I think that helps, okay? So if we think about these two triangles, I know that those two sets of angles are congruent. If I also think about other things that I know about angles and triangles, what else do I know about the angles in a triangle? They all equal 180. So in this triangle, angle A plus angle B plus angle C equals 180. And in this triangle, angle D equals angle E plus angle F equals 180. Okay, that might be helpful. Well, if A plus B plus C equal 180 and D plus E plus F equal 180, wouldn't they equal each other? Okay, so once again, just kind of thinking ahead here. Okay, so I've got A plus B plus C equals D plus E plus F. Okay, what I'm trying to do is say C equals F. Okay, I'm just trying to get a C and an F. Right now I've got A, B, C, D, E, F. So I need to get rid of the A and the B and the D and the E. But here's the thing. A and D are the same thing. So if I've got an A over here and a D over here, if they're the same thing, couldn't I just subtract that from both sides? And I could do the same thing with the B and the E. I've got a B over here and an E over here. If it's the same thing, I could just get rid of that from both sides. And all I'd be left with is C and F. Okay, so that's kind of where we're going. Okay, now, I had somebody ask me the question yesterday that they just weren't really sure when you use the angles and when you use the measure of angle. This is an instance where I'm going to have to use the measures, okay? When I'm talking about angle A, I'm talking about specifically that angle, like the actual angle itself. Angle A, right there, okay? What I'm going to end up doing is I'm going to say, okay, angle A and angle B and angle C together equal 180. I'm not talking about the angles anymore. I'm talking about their measures. I'm talking about the number, right? The measure of angle A, okay? The number associated with that. So that's whenever you're going to have to translate that into measures. So what I need to do is I'm going to need to talk about the measure of angle A and the measure of angle D. So that's going to be my next step. I'm going to say, okay, well, the measure of angle A equals the measure of angle D, and the measure of angle B equals the measure of angle E. And I know that because that's just the definition of congruent angles. So the next thing I want to do is I want to say, okay, well, I know that these three angles added together equal 180. Now, not the angles itself, the measures of the angles. I know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And in that same step, I could say, well, the measure of angle D plus the measure of angle E plus the measure of angle F also equals 180. Now, how do I know that the three angles in a triangle add to be 180? It's not technically the definition of a triangle. It was a theorem, I think, from last chapter. Talked about the sum of the angles in a triangle equal 180. This is what those flip books are for, right? The triangle angle sum theorem. The triangle angle sum theorem says the angles in a triangle add to be 180. Okay, now remember what we said. Once I have A plus B plus C equals 180 and D plus E plus F equals 180, I can set them equal to each other. Okay? So we're going to say the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle D plus the measure of angle E plus the measure of angle F. Why am I able to swap those out and do that? Substitution. Yep. I'm substituting something that's equal to something else into a different spot. Okay, now remember, what I'm trying to do, I'm trying to get just the C and the F. Okay? So what I need to do is I need to get rid of the A and the D and the B and the F. Okay? So I'm really wanting to, I think in the end, subtract those from both sides, but you can only do that if you subtract the same thing from both sides. So I need these to be the same thing. I need A and B to be the same thing. I either need them both to be the measure of angle A or the measure of angle D. It doesn't matter which way you do it. Okay? And I need both of these to either be both the measure of angle D or the measure of angle F. Or E. It does not matter which way you go, you'll get the same answer. Okay? Let's leave step 5. Let's leave the first one the same. Measure of angle A plus the measure of angle B plus the measure of angle C equals. Now, instead of D, let's substitute the measure of angle A in for the measure of angle D. And I can do that because remember, the measure of angle A and the measure of angle D, they're the same thing. So I can substitute it in right there. And let's do the same thing here. Instead of the measure of angle E, let's use the measure of angle B. And once again, I can do that because I know they're the same thing. I can swap those in. And then we'll leave this as the measure of angle F because I don't have a relationship without the measure of angle F yet. And why am I able to do that? Substitution. We're almost done. So I've got two sides of the equation. On the left side and on the right side I have the measure of angle A. And on the left side and on the right side I have the measure of angle B. I can just get rid of both of those, right? So I can get rid of the A's, I can get rid of the B's. So now I have the measure of angle C equals the measure of angle F. Now you don't have to show that step about how you're getting rid of it, like math-wise, but you do have to say why you're able to do that. Why am I able to just get rid of the measure of angle A and the measure of angle B on both sides? This is the subtraction property of equality. You can subtract the same thing from both sides. Now remember, you may think we're done. We're almost done, okay? But I already know that the last line of my proof should be this. It will always be, whenever you're trying to prove the angle C is congruent to angle F, that should always be the last line of your proof. So you are not finished until you say angle C is congruent to angle F. And I'm able to make that last step because definition of congruent angles. There we go. Not much shorter than the other proofs we did, but maybe a little bit simpler. The next proof we do later in units is even simpler than that. Okay. I don't think we did your table of contents in class yesterday, but your table of contents should be on page 47. Table of contents should be on page 47. Your vocabulary, when you finish with that, should be on page 48, which means this is going to be on page 49, section 4.1, congruent figures, congruent figures. All right, so we are going to start with this idea. We have two triangles. We have triangle ALG that is congruent to triangle ICT. Complete each of the congruent statements. Now, if you wanted to, you could draw a picture. But remember, you don't have to draw a picture because you can tell just by the order of the letters which angles are congruent by the order of the letters, and you can even tell which sides are congruent also by the order of the letters. So, for example, number 1. The segment AG, okay? So if we start with the segment AG, now if you look at triangle AG, A is the first letter and G is the last letter. So in the other triangle, the corresponding side to AG is going to be the side that has the first letter and the last letter. So what side is going to correspond to AG? IT, the first and the last. IT. So looking for the letters in the same order. What if I'm looking for angle T? Angle T. So I'm looking for the angle that corresponds to angle T. So if T is the last letter, what angle is going to correspond to angle T? Angle angle G. Very good. What if, okay, I have triangle CIT. Triangle CIT. So it's the same triangle, just kind of rearrange the letters a little bit. So you have to rearrange the letters in the same way in the other triangle. So what would that second triangle be? LAG, right? CIT goes middle, left, right. LAG, so triangle LAG. Okay, does that make sense how we use the naming to find the corresponding parts? Okay, time for some pictures. Okay, so let's start off with our statement. Triangle ABC is congruent to triangle EFG. Okay, my first triangle, ABC, will look and label like that. Doesn't have to be perfect, just kind of get the general idea. Triangle EFG is just going to kind of be like the mirror image. EFG, kind of, and even though it's obviously not drawn to scale, these are congruent, which remember means they're the same shape and the same size. Also means that their corresponding parts are congruent. Okay, so angle B, we're going to say that angle B is 30 degrees. Side AC is 10. Angle G is 75 degrees. And side EF is 15. So that's the information we are given. So I want to use that information. Let's find the measure of angle F. I want to find the measure of angle F. So this angle right here. Remember, these triangles are congruent, which means the measure of angle F is the same as the measure of the corresponding angle in the other triangle. Now, just looking at this, which angle corresponds with angle F in the other triangle? B. What is the measure of angle B? Okay, number 5. What if we want to find AB? Now, pay attention to the notation here that I didn't put the line over top, because the line over top would be referring to the actual segment. Okay? When I don't put the line over top, it's talking about the measure of AB, the length of AB. Okay? So, the length of AB is going to be the same as the length of what segment? EF, the first two letters. What is the length of EF? 15. Okay, easy enough. Okay. All right, now we got a real good pictures here. Okay, so number 9 is going to be like a little sideways bow tie thing. This. There we go. Oh yeah. So like these two lines are parallel-ish looking, like a bow tie, but just like slanted, or an hourglass, just slanted a little bit. Okay, and then let's label the triangle. So we'll do A, B, C, D, E. And let's say AB is 8, BC is 4, AC is 6, CE is 6, ED is 8, CD is 4. Got all of our sides. And then let's say angle A is congruent to angle E. Angle D is congruent to angle B. Okay, lots of information. Now, if you're going to conclude that the triangles are congruent, that means that you know for a fact that all of the angles are congruent and all of the sides are congruent. So let's start with the sides. Do I have a set, 3 sets of congruent sides? All right, 6, 4, 8. Yeah, so I've got the same sides. Now, the angles also have to be congruent. And I know that A and E are congruent, I know that B and D are congruent, but I don't know about these angles here. They don't tell me they're congruent. So there's one way to think about it, right? We could use the third angles theorem, right? That if the 2 angles from a set of triangles are congruent, the third angle is congruent. Yeah, so I know these angles have to be congruent and the triangles are congruent. How else do you know those angles are congruent? They're vertical angles. So either way, yeah, either way. So I can say, yes, they are congruent. And let's go ahead and let's practice naming these angles, these triangles. So let's start with the first triangle. It doesn't really matter how you name the first triangle. So let's just call it triangle ABC, but you could technically do it in any order. What matters is the second triangle is named the same way. So if the first letter is A, the first letter in my second triangle needs to be the angle that corresponds with A. What angle corresponds with A? E, yeah. What angle corresponds with B? D. And what angle corresponds with C? Good. Okay, let's do one more of those. So this triangle will be a little easier to draw. Let's just do a big, wide triangle like this. And we'll do A, B, C, E, and those 2. Remember, those marks mean that the sides are congruent. And that's all. Remember, if you're going to conclude that this triangle, these 2 triangles are congruent, you have to know for a fact that all the sides and all of the angles are congruent. Now, I know that these sides are congruent. Those sides are congruent. It's the same side, right? Do you know that these sides are congruent? They sure look like it, don't they? But if it's not marked, I can't conclude that. So that alone, we could say no. They're not congruent triangles. But also, what about the angles? Do I know anything about the angles? Nothing. So no. They may look congruent, but it does not matter. Okay, what I need you guys to copy down for this one, you are just going to need triangle KMB. Triangle KMB is congruent to triangle RPT. Triangle KMB is congruent to triangle RMB. We're on number 8. Okay, so knowing that these triangles are congruent, here's what I tell you. The measure of angle B equals 2x minus 4. And the measure of angle T equals 3x minus 12. So I have these 2 triangles, I know they're congruent, and they give me the measure of angle B and the measure of angle T. Great. What do you know about the measure of angle B and the measure of angle T? Yeah, you see how the B and the T are both the last letters? Which means they're congruent, which means these are equal, right? So I can say, well, 2x minus 4 equals 3x minus 12. Solve for x. So subtract your 2x from both sides. So we have negative 4 equals x minus 12. Add your 12 to both sides, we get x equals 8. Which is great, that's awesome. But that's not what it asks for. It said find the measures of the angles or the sides. So I have 2 angles to find. Do I need to plug 8 into both of these? Why not? They're congruent, they're the same thing. So I can just take 2 times 8 minus 4, which would be 16 minus 4, which would be 12. Okay, and lastly, we're going to end with a proof, okay? Okay, this given information is going to be a lot, so I think it'd probably be easier if you just do your best to kind of copy it down with me as I say it, okay? So given, we're going to be given a lot of information. You ready? Okay. Side LM is congruent to side LO. Side, hold on. Okay, side MN is congruent to side ON. Angle M is congruent to angle O, and angle MLN is congruent to angle OLN. The picture definitely helps on this one. I do have a picture coming, okay? But what we're trying to prove, we are trying to prove that triangle LMN is congruent to triangle LON. And then let me give you your picture. So the picture is going to be a triangle, two triangles that look like this, kind of setting on top of each other like that. And the vertices are going to be labeled L, M, N, O, like that. And it also tends to be helpful to go ahead and mark the triangles with all of our given information. So LM is congruent to LO. MN is congruent to ON. Angle M is congruent to angle O. And then MLN is congruent to OLN. So we know all of that information. Okay, now, in our proof, I'm going to let us skip some steps here just because we are short on time. You normally will not be allowed to do this, but I'm feeling very kind today. Okay, so let's do our statements and our reasons. Here's the step we're going to skip just because we are short on time. My first statement is going to be the given, and that's a lot to write. So we're just going to say given, okay? You normally need to write that because you won't have to write it, but we just did. So we're going to skip that one. Okay, now, if I'm trying to prove that these triangles are congruent, I need to be able to show that all of the angles are congruent and all of the sides are congruent. The information they give me, they tell me that two of the angles are congruent to the other two angles, and that two of the sides are congruent to the other two sides. So what I need to do is I need to be able to show the other set of angles are congruent and that other side is congruent. So let's start with the angles. How do I know that angle LNM is congruent to LNO? Elijah? Yes. Okay, so it's the theorem you guys just wrote down in your flip book. The third angles theorem? Yeah, the third angles theorem says that if two angles in one triangle are congruent to two angles in another triangle, the third angle is congruent. So we can say, my second reason is going to be, we know that angle LNM is congruent to angle LNO because the third angle theorem. Okay, so now I know all of my all my angles are congruent. Now I need my sides. So I know that these sides are congruent and these sides are congruent. How do you know that LN is congruent to LN? It is the same side, but there's a property that says LN is congruent to LN. And it was one that I think whenever we talked about it, I think it was back in chapter 1, maybe chapter 2, that you guys looked at me like I was crazy because you're like, why do we need to write that down? When are you ever going to need it? Because of times like this that you can't just assume it's the same thing, you have to say it. How do we know that something is congruent to itself? is the property, not symmetry, reflexive. It is the reflexive property of congruence. Now, what I've done, I've shown that all three angles are congruent and all three sides are congruent, so I can say the triangle LMN is congruent to triangle LON. And this would just be the definition of congruent triangles.